Hey everyone, I hope you're doing well today. In this video, we're going to practice solving more one-step equations, but in this particular video, all the equations are going to have multiplication as their operation. When solving one-step equations that have multiplication as the operation, there are two properties that we want to be able to use. Because each equation is going to have multiplication as the operation, division is the inverse operation, so we'll do that to both sides of the equation to solve for the variable. After using the division property of equality, we're going to use the identity property of multiplication. This just means whenever you multiply any value by 1, we don't have to write the 1. Throughout this video, we're going to cover 10 different examples of solving one-step equations with multiplication as the operation. These are the first two equations we'll go over. Here's a couple more, and a couple more. Then we'll try some with some rational numbers like fractions and decimals, and finish up with a couple more of those. While it may not look like it, each of these equations has multiplication as the operation. Between each of the coefficients and the variables, there's an invisible multiplication symbol. Here's where they are. In all 10 of these examples, we'll start by dividing both sides of the equation by a given number, and then we'll use the identity property of multiplication and drop the 1. Before we go into these 10 different examples, I encourage you to grab some paper and something to write with first. Whether you just want to sit back and relax and watch how I solve each of these equations, or you want to write them down and do them with me, I hope you find some value from this video. Let's get into it. For example 1, let's solve the equation 4x or 4 times x is equal to 28. 4 times something is 28, and let's solve for that variable x. So remember there's a multiplication sign here, and 4 is being multiplied by x. To solve for this x, we're going to use the division property of equality and divide both sides by 4. We're going to use fraction bars to show division. We're choosing to divide both sides by 4 because when you take 4 and multiply it by x, but then you divide it by 4, these 4's essentially just cancel each other out and we're left with 1. On the left side, we're just going to have 1 times x left. On the right side of the equation, 28 over 4, or 28 divided by 4, is equal to 7. Since 1 times x is just going to be x, we can write x is equal to 7. There's our solution. When we divided both sides by 4, we use the division property of equality. And when we drop the 1, we use the identity property of multiplication. For example 2, let's solve the equation negative 3y is equal to 27. So we know this negative 3 is being multiplied by the y, and so to solve for y, we're going to have to divide both sides by negative 3. By doing so, we're going to be able to get a coefficient of 1 for y. Anything over itself is just equal to 1, so this negative 3 over negative 3 is just 1 whole, and we're left with 1 times y on the left side of the equation. On the right side of the equation, 27 divided by 3 is equal to 9, so 27 divided by negative 3 is equal to negative 9. Now that we have a coefficient of 1 for the variable, we can go ahead and drop it and write that y is equal to negative 9. There's our solution. The division property of equality lets us know that we can divide both sides by any value like negative 3, and we don't need to write the coefficient of 1 because of the identity property of multiplication. For example 3, let's solve the equation 2z or 2 times z is equal to negative 26. So we know this 2 is being multiplied by the z, and to get rid of it, we can cancel it out by dividing both sides by 2. When we multiply z by 2 and then divide it by 2, we're essentially just saying that we're going to be left with 1z at the very end of the day. So we have 1 times z left on the left side of the equation. On the right side, if we know that half of 26 is equal to 13, then half of negative 26 is going to equal negative 13. We got our coefficient for z to be 1, so we don't need to write it, and we can say that z is equal to negative 13. There's our solution. There's the division property of equality, and there's the identity property of multiplication. For example 4, we have the equation 56 is equal to negative 14a, or negative 14 times a. So we know this is being multiplied, and we need to take a look at this negative 14 because negative 14 is on the right side as the coefficient, and if we divide both sides by negative 14, we'll be able to get 1a. So let's go ahead and do that. On the left side, 56 divided by 14 is equal to 4, so 56 divided by negative 14 is going to equal negative 4. On the right side, the negative 14 over negative 14 will cancel out to make 1, and we can write 1 times a on the right side. It's good that we got our coefficient to equal 1 because we can now say that negative 4 is equal to a, or say that a is equal to negative 4. There's our solution. And as usual, these are the two properties we use to solve the equation. For example 5, we have the equation 5b or 5 times b is equal to 12. So we know we're multiplying b by 5, so that's our coefficient. So let's see how we can get rid of this 5. To get rid of it, we can go ahead and divide both sides by 5. On the left side, these 5's will cancel out with each other and we'll be left with 1 times b. On the right side of the equation, 12 divided by 5 doesn't happen to be a whole number because there's going to be a remainder. 5 fits into 12 2 whole times with 2 left over, so we can write 2 2/5. And if you prefer to use decimals instead of fractions, you can say that this is equal to 2 4/10, or 2.4. Now let's go ahead and drop that 1 and say that b is equal to 2 2/5, or we can say that's equal to 2.4. Either one is okay, but there's our solution. For example 6, we have the equation negative 18 is equal to 4c, or 4 times c. To get rid of this 4 as our coefficient, let's go ahead and divide both sides by 4, just like this. On the left side, 4 won't fit into 18 perfectly. There'll be some sort of remainder, so we know we're going to have a fraction or decimal. And let's see how many times it fits in. Well, 4 times 4 is 16, so that's pretty close, but we have 2 left over, so we're going to say that's 4 2/4. We have a negative here, so this is negative 18 divided by positive 4, and that's going to be negative 4 2/4. On the right side, these 4's are going to cross cancel, and we can write 1 and 1, and say that on the right side we have 1 times c. Simplifying the fraction to the left, we can say that negative 4 2/4 is the same thing as negative 4 1/2, or we can write the decimal form, which is going to be negative 4.5, and on the right side we can drop that 1 and say we just have c on the right side. Turning this around, we can say c is equal to negative 4 1/2, and again, as a decimal, we can say it's equal to negative 4.5, or negative 4 5/10. Here's where we use the properties for example 5, and here's where we use them for example 6. For example 7, we got some decimals going on. We have 0.7d, or 7/10 times d, is equal to 8.4. So we know we have multiplication as our operation, and to get rid of this 0.7, or 7/10, we can divide both sides by 0.7. On the left side, these 0.7's are going to cancel out when we're left with 1, so we can write 1 times d on the left side of the equation. On the right side, we have to see how many times 0.7 fits into 8.4. So if you want to, you can go ahead and multiply both of them by 10, or slide both of their decimals to the right one spot and see how many times 7 goes into 84. We know 7 times 10 is 70, and that's 14 away from 84, which is just 2 more 7's. So based on that, we can say that 0.7 fits into 8.4 12 times. If 7 fits into 84 12 times, then 0.7 fits into 8.4 12 times as well. Let's go ahead and drop that 1 and say that d is equal to 12. There's our solution. For example 8, we have 2/3 e is equal to 10. So we know this 2/3 is being multiplied by e, so we're taking 2/3 of some number, and that's equal to 10. So let's see, how can we get rid of this 2/3? Well, just like the last few examples, we can go ahead and divide both sides by 2/3. 2/3 divided by 2/3 is going to equal 1 for us. Well, we could also solve this equation by using the multiplicative inverse. I'll save that for another video. On the left side, these 2/3 are going to cancel out with each other to make 1, and we can write 1 times e on the left side of the equation. On the right side, we have to take 10 and divide that by 2/3. So let's go ahead and write that on the side here. So 10 as a fraction is going to be 10 over 1, and we're going to divide that by 2/3. Now, if you're a little rusty on dividing fractions, here's a little refresher. We'll keep the first fraction alone and leave it as 10 over 1, and when we divide by fractions, the algorithm is just to multiply by the reciprocal of the second fraction. So we're going to take that 2/3 and flip it upside down to write 3/2. Now, we could just multiply across, but we could also cross cancel a little bit here. So this 2 and 10 have a common factor of 2, so dividing them both by 2, we get 5 and 1. If we were to go ahead and just multiply now, 5 times 3 on top is 15, and 1 times 1 on bottom is 1, so we know that 10 divided by 2/3 is equal to 15. Evaluating the right side of the equation, we're left with 15. If we know that 1 times e is equal to 15, that means that e has to equal 15. There's our solution. While I know working with fractions and decimals can be a little bit annoying, keep in mind that we still use the same properties and use the same algorithms for solving these equations. For example 9, we have the equation 4/5 f is equal to 16. So 4/5 of some number is equal to 16, so to get rid of this 4/5, we're going to have to do the same thing we've been doing and divide both sides by 4/5. On the left side, these 4/5 are going to cancel each other out, which was the whole point, and we're left with 1 times f on the left side of the equation. To figure out what 16 divided by 4/5 is, I'm going to go ahead and write that out. So 16 as a fraction is 16 over 1, and we're going to divide that by 4/5. So remember, when we're dividing fractions, we leave the first one alone, and we multiply by the reciprocal of the second one. So that's going to be 5/4. If you can cross cancel, totally go for it. 16 and 4, we can write 4 and 1, dividing them both by 4, and then let's see what we have here. On top, 4 times 5, that's going to be 20, and on bottom, 1 times 1 is 1, so this all turns out to just be 20, okay? So 16 divided by 4/5 is equal to 20. Dropping the 1, we can conclude that the solution is f is equal to 20. For example 10, we have 7 and 1/2 is equal to 1/4 of g. So here we have multiplication, and we need to figure out how to get rid of this 1/4 and turn it into a 1, and we can do so by dividing both sides by 1/4. On the left side, let's figure out what 7 and 1/2 divided by 1/4 is. So to begin, we need to turn 7 and 1/2 into an improper fraction. So 7 times 2 is 14, plus 1 is 15, so that's going to be 15 halves, and we're going to divide that by the 1/4. Just like earlier, when we divide fractions, we're going to leave the first one alone, write 15 over 2, and we're going to multiply by the reciprocal, which is going to be 4 over 1. If we can cross cancel, totally go ahead and do that. The 2 and the 4 are going to make 1 and 2, and then we can go ahead and multiply, and 15 times 2 is going to be 30, and on the bottom, 1 times 1 is 1, so this all turns out to just be 30. Now that we figured out that 7 and 1/2 divided by 1/4 is equal to 30, we can just simplify the left side of the equation to write 30. While that part was more difficult, here's the easy part. These 1/4 are going to cancel each other out to make 1, and we're going to write 1 times g on the right side of the equation. If 30 is equal to 1 times g, that means that 30 is equal to g, or we can say that g is equal to 30. There's our solution. And just like the first 8 examples, we use the division property of equality first, then we use the identity property of multiplication. And while you definitely don't have to write the properties when you solve your equations or even write the one, hopefully by showing you them consistently in this video, it helped you visualize and understand them a little better. If you gained some value from this video and you want to support this channel, you can do so by giving the video a thumbs up and even leaving a comment in the section below. As always, keep up the great work, and I'll see you in the next one.